Alright, so after we have looked at pre-order traversal and post-order traversal, so let's have a look at binary tree in-order traversal. That is problem 94. So the problem is that given the root of a binary tree, so we are required to return the in-order traversal of its nodes values. So the in-order traversal is that we first traverse the left subtree, and then we traverse the node itself, and then we traverse the right subtree. So let's first look at one simple example. So in this example, if we do in-order traversal, so we first look at the left subtree, which is null. Then we look at the node itself, it's 1, so we get 1 in the output. And then we look at the right subtree, that is the tree 2, 3. So for this subtree, we look at the left subtree, that is 3, so we get a 3 here. And then we look at the node 2 itself, we get a 2. And 2 has no right subtree, so we stop here. So we get 1, 3, 2. So this example is sort of simple. Let's look at another examples. So here is another 2 examples. We want to demonstrate the thought on how to write the code. So when we look at the left graph or left tree, so when we look at the in-order traversal, we want to first look at the left subtree of 5. That is the subtree with root 30. So then if we traverse this subtree, we're going to look at its subtree. That is a node with 40, right? So because 40 has no left subtree, so we first traverse 40, so we get the first element in the output, that is 40. So after we saw this 40, then we are going to look at its right subtree. But here 40 has no left right subtree, so we come back to see 30. And after we saw 30, then we examine its right subtree, that is 50. So we get 40, 30, 50, and so on. We're going to get 40, 30, 50. And then we look at the root value. Then we do the same for the right subtree. So using same process, we can get the in-order traversal for the right tree, right graph tree. So that is 30, 50, 5, 4, 2. So the common thing for these 2 traversal is that when we examine the root, so we want to go to the very left until the node has no left subtree. Then we output that node value, then look at its right subtree or right children. So that's basically the overall idea. So now let's come back to the original problem. So first we're going to translate the explanation just now into code. For that purpose, let me first initialize the result, whose final state is what we want to return. And again, I'm going to initialize a stack which is going to store the nodes. And then I want to set the current as a current root. So the current is a running variable. So now we are going to iterate. So actually we have already incorporated the special case if root is null. So let's look at the while loop condition. While current or s. So actually if the currently its state is root, if root is null, so we didn't enter this while loop, right? So once we enter this iteration procedure, we are going to first traverse to the very left, right? That is another while loop because we want to continuously traverse to the very left. So while current, then we are going to move to the left. So first I want to append this current to our stack, then I'm going to reset current to be the current left, right? So once we are done this, we're going to look at another logic. So once we come out of this while loop, the current will have no left child, or more precisely, the current will have a status that is null. So then we'll examine the current by popping from the stack. So that's the role of the stack. So now current will equals s pop. Think of the 50 in the graph. And then what we want to do is that, so we add this current value to the result, because we are traverse to the very top left, and then we add the value of the current to the result, and then we examine its right child. So we are going to set the current to be current right. So that's the procedure exactly explained minutes ago. So this way we are finishing the traversal procedure. So now let's return the result. Let's first do a check for example 1. Yeah, it passes example 1. Now let's check the generic case. So yeah, it passes the generic case. So this is the in-order traversal. In some sense, this in-order traversal is slightly complex than the pre-order and post-order traversals. And also, as in the previous videos on pre-order traversal and post-order traversal, we can also write a recursion solution, but that's sort of trivial. But for completeness, I'll write it again here. So I'll call this first one as V1. And then for the in-order traversal, what we want to do is that I'll first check if not root. I'm going to return a empty list, and then otherwise we're going to do self in order. So in order traversal, and then we traverse the root left, and then we concatenate it with the root value, and then we traverse the right. In order traversal and root right. Then we're going to submit directly. Yeah, it passes the generic case. So that's about the solution, or one solution for the in-order traversal. So here actually we emphasize on the iterative way. The reason, as we had mentioned in the previous two videos, we are going to use the iterative solutions for these traversals to attack more complex problems by incorporating more complex logics. So with that said, I guess that's about it for this algorithm. Thank you.